Yes, it's the first calculus part.
It's like,
No, it's
really true.
that was a 37 on
Today's just intro.
36 if I made the putt.
Not yet, though. Is my pencil not good enough for you, Logan? All right, angle conversion is what we're going to talk about. We're going to talk about all kinds of different ways to measure angles. But whenever I'm talking about measuring angles, I'm no longer just talking about some rando angle that I draw here. I'm going to be talking about angles in a coordinate plane, okay? So, I've got my XY axis, yes. Oh my gosh. Give me a variable you use frequently to describe an angles measure. Y'all might not know this yet. Have you ever seen this? Theta. Yeah, theta. Theta is your angle degree measure. It's what we use most often to denote degrees, or not even degrees, because we're going to talk about other stuff, but angle measure. Okay? No. Huh? Theta. Yes, yes. Right now. Because a lot of people have. Okay. Now, as we look at these angles, we're going to position them in what we call a standard form on the coordinate plane, which means the vertex is going to sit at the origin. The initial side of the angle will be the x-axis here. And then we rotate around this way. We rotate around counterclockwise to get to the terminal side of the angle. So this angle is measured this way, and that is theta, my angle measure. That is an obtuse. Why is it obtuse? That's awesome. Y'all are great. We're not going to use that information. This is the initial side. This is the terminal side. I hope you guys remember special right triangles from geometry, like 30, 60, 90, and 45, 45, 90, because that we will use in here. Now, terminal, yeah. Now, if I measure the other way, because I can measure the other way, if I measure it counterclockwise, so I'm still starting here, or clockwise, sorry, clockwise. I'm still starting here, but I go this way. What happens is this makes my theta negative. If I say less than 0, you know what that means? Greater than 0 is positive and less than 0 is negative. So I could go either way. So, what block is it? What's this for? Oh. All right. Now, if I asked you, actually tell me how many degrees I have if I just click up the quadrants here. In other words, what? Here. This is 90 degrees. That angle would be, the theta would be 90 there, right? I could loop all the way around, and that would be 180. Around all the way to here would be 270. And then all the way around, one complete loop around, 360 degrees. Everybody okay? They are a little messy, I'm sorry. All right. What if I asked you to graph in standard position, graph the angle measuring roughly 60 degrees? Where would you put your terminal side? Terminal. It'd be on this side.
Over half.
About right there. This is about 60 degrees. Okay? Oh my gosh, no. What? Are you making a bracket or something? Bro, I can make them, I can still have an opinion.
Yeah, Kenzie.
Don't
talk to your mom like
bracket.
I put a staple in there.
She did make a bracket
She
last
made a bracket last night.
Are we gonna win the first one? Well, it was fun playing Morgan.
Logan, come here. Come here. Come here. Like, get up and walk here. Draw an angle that has a measure of roughly negative 110 degrees.
377. That's right. I don't know. I'm just kidding.
That's actually,
Yeah.
that's right. That's right. That's right. You did it real quick. Okay, tell him what you did. Tell him what you did, Logan. Negative means I'm going clockwise, right? So I'm starting here and I'm rotating this way 110 degrees. Each quadrant here is 90. So you go 90 in the little passage. If you go too far, you've made it 180, right? So that's about negative 110.
About 100.
Wow.
Now,
I really don't know how I did that.
I know, that was quick. I was impressed. Bless you. Wait, bless you. Now, we can have what we call coterminal angles. And what that means is, like if you look at this, and this is 110, negative 110, right? Can you think of another way I could describe that angle? Positive what? Do something. Do what? Tell me what you're going to do. So this, I could say same thing as 250 degrees. Would you agree? If I start here, guys, and I rotate around 250 degrees, I end up back at the same place, and that's what I'm looking for is this terminal side anyway. So we have what we call coterminal angles, which means as I loop all the way around and I keep looping around, they come up to the same thing. So they're same angles with different measures. So to find them, what are you doing? To find these, I add Can you knock him for a second? Like, just punch him on the arm or something? What are you doing?
What did he do that was so wrong?
I literally was mid-sentence on how you find a coterminal. Hey, you know what I got on the reading quiz? Okay, here's what I'm going to do. I add increments. And I should say add or subtract. Increments of 3. Okay. So I could have an infinite number of coterminal angles. All I'm doing is continuing to loop myself back around and end up back at the same place. So a coterminal angle with 250 or negative 110 might also be what? Give me another coterminal angle. Oh my gosh.
What question is that?
Give me, so we're naming coterminal angles. Negative 110. 250, give me another coterminal angle. What?
Oh, you can do. No, hold on. I got you. Hold on. Negative. Yeah, you just add 360 to it. coterminal would be 970. Oh, yeah,
It's not another coterminal for this one?
810.
Yes, tell me what you're doing, Davis.
I
Tell
literally
everybody
said
what you're doing.
970 and you said,
I didn't hear you.
you look at me and said,
I can't imagine why I can't focus in here. I'm going like this. Okay. I'm adding 360 each time. I'm adding increments or subtracting increments of 360 because all I'm doing is continuing to loop around, and I still, if I go 360 degrees from this spot, it's a complete revolution around the circle, so I'm back where I started. Shoop, back it there again. Add 360 again. Shoop, I'm back right there again.
Negative 4.
Yeah. I could go that way. But you're wrapping the other way, so I got to go shoop that way. All right, yes, no, maybe so. How many degrees? Noah, how many degrees altogether in a circle? 360. How do I find coterminal angles? Add 360 or subtract 360.
Yeah,
Continue to do that. Continue to do
There
that.
we go.
I can do it like this.
That's right. Yeah. Talk that
All
talk.
right, let's do the new stuff then. All right.
Stop playing with him, Mr. McGee.
All right, homework.
Degree, measuring an angle with degrees is elementary. We won't do that much more. Once we hit pre-cal level, we move into another way to measure angles, and that is radian. If you did not do this in any type of pre-cal math class, then you got robbed. Like in algebra 3 pre-cal. I'm sure you did because we don't measure past geometry. We don't ever use degrees.
I don't know really.
All right. Yeah. Radians, Radians. The book bag's under my desk.
Ow.
All right. Listen. All right, y'all focus.
He's already had one.
I'm on my circle, right? I know this was 0 degrees. This was 90 degrees. Get to lunch. This was 180 degrees, 270 degrees. In radians, one full loop around the circle, all the way around, is 2 pi radians. We're going to get there tomorrow. 360 degrees is 2 pi radians.
Come on, hot pocket. I should probably write this stuff down.
Very important. 360 is all the way around the circle. 360 degrees is the same thing as 2 pi radians. Okay? Yeah. Which means at 180 degrees is 1 pi. There you go. The unit circle starting to pop out at us. Hi, what do you need? Pi. All right, guys, I am struggling with you. All right, pi is 3.1415, right? But that's radians, okay? So even though you could get a decimal, this is how we leave answers exact. You know how whenever we were working with radicals and we left the radical in there because otherwise we were rounding? Same thing here. We leave the pi in the answer so that we have an exact answer, okay? Now, somebody said that means up top is a half of a pi, and that's right. It's pi over 2. which means down at the bottom is 1.5 pi, 3/2 pi, which is 3 pi over 2. 270. Okay. As you can see, we are starting to get these points on this unit circle. We'll have the full thing filled out very, very soon. Not today, but very, very soon. All right. 3 pi over 2. 90 pi over 2. All right. Now, is what? Yes. All right. Now, we can also have coterminal angles when we are in radians. Doesn't have to just be in degrees. Okay? So, but this time, if I need coterminal angles in radians, I'm not adding 360 degrees or subtracting 360. Instead, I'm adding or subtracting what? I'm adding or subtracting what? 2 pi. Because that's my complete circle now. 360 is the same thing as 2 pi. Is everybody okay? This is brand new. I'm assuming 90% of you have never seen this before. Okay. Even you, Logan?
Nah, I think we just did little. Like we had a.
They didn't do this.
We had like one little. Why did we have
All right. No, because pi is only halfway across the circle. So if I was right here, let's say I was at pi over 4. To find a coterminal to pi over 4, this I would need to. Then I would need to add to it 2 pi to make it back around. Because 360 degrees and 2 pi is the same thing. Is everybody with me just on coterminal right now? We're fixing to start flip-flopping between the two to make sure you can convert, but right now, if I gave you that measure, well, if this is if a half a pi is at the top, half of a pi would be halfway in between the two. Hey, you're gonna rock out this unit circle. That's one of our unit circle values. Pi over 4, yeah, pi over 6 is 1 too. Right. Soon. Oh no, we're doing it. Okay.
Why does that one up there say 2 over pi at 9?
Where does it show this? It's upside down.
Points off, change the grid.
Because at the bottom, see at the bottom there, it's 270 degrees.
Why do we need to do a project?
You will do a project. We will have multiple quizzes. Calculus, I always ask calculus at the end of the year, what's the one thing that I could do in pre-cal to help you be more successful in calculus in the past 2 years, they have told me. Drill them with unit circles.
That's not what I heard. I heard they said you need to teach it better, not drill it.
But teaching it better, make them memorize it. Ask them. Ask them.
I was in here, that's what they said.
You can't, there's only one way to teach it. What was hard? Unit circle? Yes, no on coterminal. All right, let's convert. Did y'all do unit analysis in science? What's the word I'm trying to see wrong with me? No, between
That one,
It absolutely is. So you'll need to be very careful, and I'm going to get to that at the end, but remind me, don't let me forget, because your calculator can be in either mode. All right. Do you agree that you can multiply anything by 1 and it has the same value? Okay. If I start in, and let's start in one we know. I know 180 degrees should give me how many radians? 1 pi radians, right? So what I'm going to do is I'm going to multiply by. Now remember, if something's on the top and the bottom, it cancels out, right? Actually, let's not start with 180. Let's start with, because that's what I'm going to use. I'm going to use that for my conversion part. Let's start with, we'll do 90. I know, this is like 90 degrees over 1, right? I know that in 180 degrees, how many pi's are there? 1 pi, right? I don't know.
It is, Coach Young, too. No. You want a key chart, Mr. D? I'll write it down.
Okay. This is what we call unit analysis in math.
We are doing a T-chart, so you can see it up, right? 90 degrees. Oh, that was not applied. Hold up. My bad.
Oh, I know what you're doing. We're not doing all that because we're not
180
moving more than one.
That's
We're not
what
moving more
equals
than one off.
90 degree pi over 180. Boom. T-chart. Except
Let me tell you why we're not going to do that.
you would do this when you have like moles.
Because I have to get you ready for an AP exam, and our readers on that would look at you and go, we're not checking for that. Okay. That is definitely not true on an AP exam. But it's pre-calculus, so I have to get you ready for calculus. That's my job. It's literally what the class means. Okay, so I could go ahead and divide by 10, of course, which would give me pi over 2, which is the correct conversion. So, in a nutshell, to go from degrees to radians, 2 radians, multiply by pi over 180. How do you think I go the other way? What if I start in radians? Yes. The other way from radians, 2 degrees, okay. As you guys are writing that, a couple of things to note. All radian measures don't have to have a pi on it. Okay. Now, if you're converting and it's there, leave it in there. But it doesn't have to have a pi. I could have pi degrees. That just means 3.14 degrees. Okay. It's just part of the conversion, and I've got an even number of pi's in my entire circle, so that's where that comes from. Y'all ready? Pi over 2. Here's what I want you to do.
Oh,
Convert it to radians and name 2 coterminal angles in radians and degrees. Mark that down. first note since you're taking this class. All angles, that's an angle symbol. So you don't get it mixed up with the lesson sign. When I used to teach geometry, that's what I did. I would use my calculator. So does everybody know how to get your calculator to give you a fraction back out? It's, yeah. But everything's not going to convert to a fraction. Sometimes it's irrational. If it can be written as a fraction, it's rational. If you can never. Pi in and of itself is an irrational number. You can't take an irrational number, put it as a fraction, and call it rational. Okay, yes. I don't know, I don't have my calculator. What's 230 divided by 180 and then put it back as a fraction? 23 over 18. So negative 23 pi over 18. Okay. There it is converted as radians. Now, what if I need two coterminal angles? And I asked you to do them both in degrees and radians. So we'll do degrees first. I think it's the easiest. Yes. Because pi over 180 is 1. So the first one, let's do degrees first. Negative 230. I always add 360. I don't ever subtract, but you certainly may subtract if you want to. What is it? 130. What's another coterminal? All right, so two coterminal angles to negative 230. What you got, Alex? The decimal, hit math, enter. You did 23 of, not the pi. Don't put the pi on there. Yeah, leave the pi off, and we just throw it in the end. All right, where did these numbers come from? Yep. So Huh? What do you mean why? I'm fixing to. What do you mean? What are you talking about? Because this is exact. It's kind of like whenever I have the square root of 8, I'm not going to write a decimal for that. I'm going to do 2 root 2, and I'm going to leave it as an exact answer. No rounding issues will come up like that. All right. Okay. You got them? Don't worry about it. He was asking me about pi and why we leave it as pi, and I was just explaining that it's an exact number. Yep. All right. You got a question? Add 360 to where I started. So negative 230 plus 360 is 130, and then plus 360 again would be 490. At what? Because it asked me for 2. I could have added 1. I could have subtracted 360. I could have said the negative 590 is another all those are coterminal. There's an infinite number of coterminal angles. I would just continue looping. Now, as I convert to radian, all right, or as I find these coterminal angles, if I'm doing this, I'm probably not converting each one of these over. I'm going to take my negative 23 pi over 18, and I'm going to add 2 pi to it, because that's my loop around is 2 pi. Because you might at some point in your heart, well, you will. You'll be given a radian value, and then it'll say find 2 coterminal values for this radian value. So rather than converting it over to degrees, adding the 360 and then converting it back to radians, I would rather just come here and say, okay, well, let's add 2 pi. So negative 23 over 18 on your calculator, enter, plus 2, enter, and then turn it back into a fraction. Math enter, enter. Negative 23 over 18 plus 2. Oh, that's not what I got. Oh, wait, I did. Yeah, 13 over 18. And what I would do is I would just keep this in my calculator and add 2 to it again. Math enter, enter. That's right.
Hey.
You got what? What happened? You should do it. Just do the 23, negative 23 over 18. Negative 23 over 18. Hit enter and then do plus 2. Math enter, enter. 2 pi. That's how I find my coterminal. Because wrapped all the way around the circle is 2 pi. So if I started here and I'm in radians, right? Whatever this angle is in radians, to find the coterminal to wrap all the way around, I would add 2 pi because all the way around the circle is either 360 degrees or 2 pi is radians. To go the other way, you could subtract 2 pi. If I went this way, I would subtract 2 pi. Yes, 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 yes. Coterminal angles. Well, okay, so you could, but what if I said, give me 2 coterminal angles? If you have the degree, sure, but you'll have to convert it back over in the end. Because if you start in radians, you want to end in radians. 2 coterminal angles. And in fact, give me 1 negative and 1 positive coterminal angle in radians. But you're adding. It is. It is. That's the way I do it. If I look at them. If I need a right. Because if I'm going to add 2 pi here, that really means I'm adding 14 pi over here. No, that's why I said I'm not going to show you. We're just doing it. We're just writing down the mental math that we're doing. We're adding the fractions in our heads with the calculator. But you do not have to. No. He asked me why I wasn't showing y'all that. And I said, because I'm just showing you how to use the calculator to let it do it. We're adding 2 pi. Why 2 pi? Why are we?
That's 360 degrees.
I literally have makeup marks where I keep banging my head right here. Why 2 pi? 2 pi because that is one complete loop around the circle. How do I find coterminal angles? If I'm in radians, I'm adding and subtracting 2 pi. Always 2 pi. It's always 2 pi.
You always add 2 pi?
Yes, or subtract. I didn't say convert. I said find a coterminal, a positive coterminal, and a negative coterminal. Well, if I have to have a negative coterminal, the only way to make this negative is if I go backwards with it. Fine. It literally says, give 2 coterminal angles for each given angle, 1 positive and 1 negative. This, you should get 16 pi over 7. And this, you should get negative 12 pi over 7.
What does the math look like when you're calculating?
2 divided by 7, enter, plus 2, enter. Math, enter, enter. Plus 2. Adding 2 pi. It seems to be the radians that we're struggling with and not the degrees, yes? We got one more thing to go with it. 12 over 7. I got negative 12 over 7 also. Right. Somebody go open the door for Slade. I'm sending somebody. Thank you, Miguel. That was very kind. The other is right here. Yes. Give me 1 positive and 1 negative. $36, 25 pi over 18 for 1. It's down as low as it'll go. How do I know that? Are you talking about how do I know that in my head, or how do I know that? What did I do? Well, I found a common denominator of 18. Since it's always 2 pi, it's just doubling the denominator each time. How about the negative? How about, all right, guys, y'all need to focus. Even if you understand, everybody around you might not. How'd you get that, Miguel? There you go. Subtract the 36 pi over 18. Unless there's some over there. I don't know. And then math, enter. Yep. All right. What am I doing? What one? Yeah, I just converted it over in my head. All right. Last thing. This was called angle conversion. Radians is the most common. I'm really hesitant to even show you DMS, but you do need it. The reason that I'm going to take some time to do it is because it pops up on SAT, ACT, and some standardized testing. Outside of that, we don't really use it in calculus anymore. We don't use it anywhere else. but I would really like to just show you so that you know it's very applicable. What? Oh, I know. That's what I told Kenzie, and I'll tell y'all too. You need to take it after you take this class, for sure. What? As soon after. What wasn't? You'll be surprised how much of it was on there. You just don't realize you could have used the circle to do it.
Well, maybe we should have done it like
Or last week.
All right, DMS. DMS is how we measure latitude and longitude. It's what's known as degrees, minutes, seconds. 1 degree has 60 minutes. 1 minute has 60 seconds. How many seconds does 1 degree have? 3,600. 3,600. One degree is 3,600. Yeah. All right. I've been up here a lot longer than what I like to stand up here, but I'm almost done. I also have not been very cooperative today. All right, let's convert. Let's do some conversion. So when I'm in DMS, I look, let me start in degrees and then I'll go to DMS. When I'm in degrees, this is whenever I have something kind of like this, okay? DMS gives me so many degrees, so many minutes, and so many seconds. This is the degree portion. This is the minute portion. This is the second portion. And this is what your latitude and longitude looks like whenever you read it. And this is where it's coming from. So what I'm going to do is I'm going to take the whole number of degrees off, which is what? 30, the whole number, the 31. 31 degrees. And I'm going to take the 0.875 and multiply it by, what do you think? 60. Yep. When you multiply by 60, what do you get? There are 60 minutes in 1 degree. So how many degrees? If I've got 0.875 degrees, how many minutes is that? Well, that's 52.5 minutes. Again, I only want the whole number part. You would be exactly right. Once I take that whole number off the front, yeah. So I took the 31 off. That's my whole degree. Then the 0.875, I multiply by 60 because there's 60 minutes in 1 degree. That gives me 52.5. I take the whole number off again, leaves me the decimal of 0.5, and again multiply by 60. And that tells me the second.
how did you do the backwards, bro? How did you do the backwards, bro?
You'll be doing quizzes in my room? How do you do it? All right, is everybody okay forwards like this? Yes. Convert to DMS. Mark, set, go. For what? For what? What did you just say? You eat it up. Co-terminal angles, degrees to radians, radians to degrees, and DMS. Oh, just DMS. What you got, Miguel? 89 degrees. How many minutes? Yes. Isn't that cool? Mm-hmm. I think that's the only person who might be better. Yeah. All right, let's go the other way with it, Kenzie. Come.
It was a rhetorical question. It was a rhetorical question.
All right, let's go the other way.
Ooh, God. That was the brother.
No one's above you.
That's right.
Write it in degrees. Write it in degrees. Mark, set, go. Write it in degrees.
All right.
All right, remember I'm in degrees. This first part is already in degrees. Okay? How many minutes are there in 1 degree? 60. How many seconds are there in a degree? A degree. That's literally how you convert it. That's it. It will be ugly. Keep this as a decimal. Yep, you'll keep this as a decimal. I got 0.15 here. 0.013. Take it out 4 places. 39. Yeah. There it is. So it's degrees plus minutes over 60 plus seconds over